Just do a quick check where did I stop the last lesson. Did I do exercise 8.1 question 2? Did I do exercise 8.1 question 2? No? Then what was the last question that stopped there? Try 3, huh? Both A and B directly, is it? Okay. Can. Okay, then let's take a look at exercise 8.1 question 2. Okay, for warm up. Okay, we want to find the radius and coordinates of the center. Of part A, which has this equation. Okay, so let's use this question to just refresh our memory about the general form. Okay, so I've introduced you standard form already. Yesterday we actually did one question using standard form as well. Okay, for general form, what I have decided to be consistent with is that for general form we just expand and then we do comparing of coefficients. Okay, and I think that is actually faster and easier lah. Alright, so looking at question 2a, okay, we want to find the radius and coordinates of the center. Okay, so in this case we are given the general form. Okay, so what we have to do is to first expand the standard form so that we know what is it that we need to compare. Okay. Right? Then what we will usually do, okay, when it comes to standard form, you notice that all the squares, they will usually put it on one side. Then all the degree 1, okay, expressions will actually be on the middle. Then after our constants. So we rearrange into as such. And our R squared will move over to the left hand side. Okay? Right? Then at this stage here, what we will do is we compare, okay, the given equation with our expanded form. Okay, so we see that the coefficient of x in this case is negative 2a and this is plus 2 over here. So that means that by comparing, I find that negative 2a equals to 2 and hence a equals to negative 1. Okay, then our coefficient of y is negative 10. We have negative 2b. So negative 2b equals to negative 10. b is equals to 5. Okay. And then the last part would actually be our plus a squared plus b squared minus r squared. That will have to be equals to 1. So a and b have already been found. So negative 1 squared plus 5 squared minus r squared equals to 1. This will come out to be 26. Okay, so 25 is equals to r squared. And hence our r equals to 5 or negative 5 when we take square root. We reject the negative 5 since radius cannot be negative. Therefore, radius equals to 5 units, and coordinates of center is -1, 5. Okay? Regarding our general form. Okay, so let's move into questions whereby it is more typical, okay, more generic, more typical regarding the topic of circles. Okay, so when it comes to the topic of circles, right, very often it will be very helpful if you could draw a diagram to illustrate what the question is asking about. Okay, so looking at try 4, it says that a circle passes through the points A, 2, 1 and B, -6, 5. Okay, so draw out a circle. You need not have it perfect. Okay, then roughly, okay, maybe put in your x and y coordinates. X and y axis. Okay, and then put in the coordinates, the points of A and B. Okay, but if you find that it's too difficult, okay, but just a circle will actually do. So 2, 1 may be around here. Okay, and B, -6, 5. Maybe around here. Okay, just an estimate, okay, to help you visualize the question will do. Take note that in this question, they say that the circle passes through A and B. They did not say that AB actually forms the diameter. So very different from the question that we did yesterday. Okay, so do not draw that assumption that the 2 points will connect to form for us the diameter. Okay. So part I, we want to find the equation of the perpendicular bisector of AB. Okay, this is where you need to actually be familiar with certain properties which you studied in E-Maths last year. Okay, as well as I think in coordinate geometry in A-Maths. Okay, regarding perpendicular bisector. Okay, so the idea of perpendicular bisector, perpendicular means 90 degree. Okay, perpendicular to what? Perpendicular to AB. Okay, so we can draw a line segment AB over here. We're expecting a perpendicular line to AB. Okay, then after that, bisector will mean that it has to cut AB into half. So right in the center, okay, maybe I label this point as M, as the midpoint of AB. Okay, so the perpendicular bisector will have to be a line passing through the point M at 90 degrees, okay, to AB itself. Okay, so the thing that we want to find is the equation of the grid line. Okay. So based on what we learned in coordinate geometry last year, right? Okay. First we find the midpoint coordinates using our midpoint formula. Okay, so we let, maybe I'll just write it up. Let the midpoint of AB M. So M will have the coordinates -6 plus 2 over 2, comma 5 plus 1 over 2. And we find that the coordinates of M would be -2, 3. Okay. So what's the purpose of us to find the coordinates of the midpoint? Okay, maybe I sidetrack a little bit. Okay, because the question wants us to find the equation. In order to find the equation of a line, we know that it is y equals mx plus c. Okay, and in order to know what is the value of m and the value of c, I always need to find out what is the gradient, and I also need coordinates of at least one point on the line. Okay, so I need these two information in order to form my equation of straight line, in case you have forgotten already. Okay, so let the midpoint of AB be M. Found the midpoint already. This midpoint is actually on the perpendicular bisector itself. The next thing is that I need to know what is the gradient of the perpendicular bisector. And that gradient, being perpendicular, will be negative 1 over the gradient of AB. Okay, so we find out what is the gradient of AB. That will be 5 minus 1 over negative 6 minus 2. y2 minus y1 over x2 minus x1. Okay, so we get negative half. Okay, so if you recall from Sec 3, perpendicular lines, m1 times m2 equals to negative 1, yeah? Okay, I'm just writing this out in case anybody has forgotten it already, yeah? Okay, so perpendicular lines is m1 times m2 equals negative 1. In other words, m1 equals to negative 1 over m2. Okay, so if you know this fact, you could directly jump into finding out the gradient of the perpendicular bisector. And that will be negative 1 divided by negative half. So that's 2. So we now have the gradient, we now have the midpoint. Okay. Then we can find out what is the equation of a straight line. Okay. Because I was not with you last year, I was just wondering, do you always use this to do your equation of a straight line, or do you actually do y minus over 3 equals to 2x minus over negative? You understand what I'm talking about? Do you all do this, or do you all do this usually? This one usually, huh? Okay, then I'll stick with this. Okay. So then y equals to 2x plus c. Okay, because gradient is now 2, so need to find c. So at the midpoint, so c is 7. X plus 7. Okay, questions? Okay, moving on to part 2. It says that the center of the circle lies on a particular line. We want to find the coordinates of C. Okay, so the center of the circle, okay, first fact that you must know, alright, from your EMATS, geometrical properties of circle, okay, the last chapter of your EMATS last year, okay, perpendicular bisector always passes through the center of the circle. Okay, so this was something that we covered last year. Perpendicular bisector has to pass through, okay, the center of the circle, okay, because remember the property perpendicular bisector of a chord. Okay, perpendicular bisector, AB is a chord itself. Okay, so because it passes through the center, that's one thing you must know. And then in this question, it says that we have this line 5x plus y equals to 0 that passes through the center as well. Okay, so that's a very important information. Okay, because if you try to illustrate this line over here, so 5x plus y equals to 0. That means y equals to negative 5x plus 0. Okay, so the gradient is negative. The line will look something like that. Okay, so maybe something like this. Okay, so this will be the line 5x plus y equals to 0. Okay, I do try to draw the diagram as realistic as possible, at least get the gradient correct, the positioning of the points roughly estimated to be correct. Okay, because if it's inaccurate, you draw it all over the place, then it may not be always helpful. Okay, so this purple line passes through the center, perpendicular bisector also passes through the center. Question will want you to find out the coordinates of the center. So essentially what we're looking for is the intersection point of both the green line and the purple line. Okay, to find the intersection point, that means we do simultaneous equation solving, do by substitution or by elimination. But usually we do by substitution now. Okay, so equation 1, then equation 2 will be what you found in part I. So find that x equals to negative 1. Okay, so C is negative 1, 5. Okay, so important fact, okay, surrounding circles, you must know perpendicular bisectors passes through center. Okay, this is a very frequently used fact when it comes to circles. Okay, the topic. Okay. Then in part 3, we want to find the equation of the circle in general form. I now already have the center of the circle. Okay, so I have the coordinates and I know, okay, two other coordinates that's found on the circle itself. So I can find out what is the radius, okay, using my length of line segment formula. Alright, then after that I can actually use my standard form already, put in the coordinates of center, find the radius, expand, then we get general form. Okay, so could I give you about 5 minutes to form out the equation of the circle in general form? Okay, in case you forgot length of line segment formula, write it here. If you're still lost at any point, please raise your hand. I'll come over to you, okay? yes, you can see that some of you are still writing. Okay, in the meantime, erase this letters. Okay, do check your answers with what I wrote on the whiteboard. Okay, you can find the radius by either finding AC, otherwise you can also find BC also, up to you. But essentially the radius should be 5. Okay, to be specific, that's 5 units. Okay, then you should get the equation of the circle upon placing it in the standard form. Okay, and then you expand it and you get this. Okay. Let you digest this. Any questions before I possibly move on? Okay. I'll erase this side of the board first. Okay, I erase this part already, yeah? Right, let's take a look at try 5. Okay. Right, in try 5, right, we are given the general form, okay, of a circle C1, okay, x squared plus y squared plus 6x minus 4 equals to 12. Okay, question asks you to find out what is the coordinates of the center and the radius of the circle. Okay, so we have been doing this so far already. Okay, so I shall not dwell so much on it. So if you're following the method that I have decided to use, which is to expand the standard form, you get this. Okay. To be honest, at some point you will probably eventually memorize the expanded form already. Okay. Okay. Then after that, you do your comparison. So negative 2a equals to 6. Negative 2b equals to negative 4. So we get a to be negative 3 and b equals to b equals to 2, sorry. Okay, then we can find out what is a squared plus b squared minus r squared. That would be equals to, what would it be equals to? A squared plus b squared minus r squared. Is it equals to 12? Matthew, what do you think? Equals to 12? Negative 12, yeah? Okay, so do be careful. This one is on the right side. So you need to shift over. So technically, it should be equals to negative 12. Okay? Then, place in the a and b. 9 plus 4, 13. Okay, so your center negative 3, 2, radius equals to 5 units. Okay, the challenge is in part 2. We want to find the lowest point on the circle, okay? So the lowest point on the circle is B. No matter how you draw a circle will always look like this, okay? So the information that we have now is that the center is at negative 3, 2, okay? And the lowest point, okay, where exactly would this lowest point be? What do you think? Call someone. Mingsan, what do you think? Where is the lowest point? Forever, regardless of what circle. Lowest point on the circle. Where will you identify lowest point? Or you want to come out and draw? Sorry? Okay. Here or here? Okay. Directly below the center, right? Okay, so the lowest part of the circle will always be directly below the center. Okay, no matter whatever size that you have of your circles, okay. So B will have to be here. Alright, so therefore, in order for us to find the coordinates, okay, we can just do it by observation. We know that the radius is 5 units. So from the center all the way to the point B, okay, it will be directly below, okay, so naturally it is perpendicularly downwards towards, as in perpendicular to the tangent at B lah, okay, but essentially there's 5 units over here, okay, so we know that it is negative 3, 2, in other words, if I have my x and y axis, okay, that means that it is Okay, let me draw my x and y axis. Okay, so this is negative 3, negative 3. Okay, so our x and y axis maybe look something like that, because down here will be negative 3, down here will be 2, right? Okay, so that means that from the y coordinate 2 itself going downwards by 5 units, okay, that will mean that it reaches negative 3. Okay, and then the x coordinate will have to be the same, which is negative 3. Therefore, our point B will have the coordinates negative 3, negative 3. Okay? So it won't be helpful for you to understand how to break out this coordinate, x coordinate, y coordinate. Okay, x negative 3, y coordinate. Alright? Okay, Jovia, can you please stay awake? Alright, so this is part 2. Now let's look at part 3. Okay, part 3 says that another circle C2 touches C1 and point B. Even as C1 and C2 do not overlap, okay, and that the area, okay, is actually following this equation over here. So area of C2 is equals to 9 times area of C1. And then we want to find out what is the equation of C2, okay, in the general form actually. Okay, so despite being written in this manner, it is actually a general form. So you need to recognize that. And then the question wants you to specify what is the value of G, F, and C. Okay, so that we can do by comparison. Let's try to comprehend the question first, since the question did not give any diagram. Okay, so we have the circle C1, actually it's the blue one that I've drawn over here already. Okay, and then it says that it touches at the point B, no overlap at all, and C2 is actually bigger because the area is larger than C1. Okay, so look something like that. Okay. Now, the thing about C1 is that we know the center is going to be here directly above B, and the center has the coordinates negative 3. Okay. For the two circles to touch at only one point, okay, without any overlap, right, it can only mean that the center of the bigger circle is actually aligned in the same straight line, okay, and in fact vertically downwards, okay, from the center of C1 to B and then coming down here. Okay, so we have these coordinates that we need to go and find. Okay, since we know that it is actually vertically down, regarding the x coordinate, okay, because it is falling on x-axis, it will actually have to be the same at negative 3. Okay, so these are deductions that we can make so far just by drawing the diagram alone and understanding the question. Okay. Alright, then if I put in the coordinates of B for us to reference later on, that's negative 3, negative 3. Okay, and then this is actually 5 units. So what we actually need to know at this juncture is the radius, okay, of the bigger circle. If I know the radius of the bigger circle, then naturally I can count, okay, from the y coordinate of B, count downwards, okay, based on the length of the radius to find out what is the coordinates of the center. Okay, so the crucial information is to find out what is the radius. And for us to find out the radius, we make use of this formula over here, okay, this given information regarding the area. Okay, I'll show you one way that we could do this, and maybe this is your natural way of doing things. Okay? So, area of C2 is actually 9 times area of C1. Since you're talking about area of circles, okay, I think that maybe intuitively, you will think about area of circle being pi r squared. Okay? So, area of C2, pi r squared, equals to 9 times area of C1. So pi r squared again, radius we know it is 5. Okay, then we know that we can take 25 times 9, and I think that gives us 225. So r squared equals to 225, and we get that r will be 15 or negative 15. So we reject the negative 15. Now we have the radius of the big circle already. Okay, so radius of big circle is now 15. Okay, so from the y coordinate of B, which is negative 3, I can now count downwards, okay, 15 units below to find out what is the center of the coordinates, the coordinates of the center of C2. Okay, so from negative 3 itself, minus away 15, we get negative 18. So therefore, center of C2 is negative 3, negative 18. Any questions at this juncture? Alright. So now that I know the radius of C2 and the center of the coordinates of the center of C2, I can proceed to find out what is the equation of C2 and finally answer the question. Okay. So I'll continue over here. X plus 3 squared plus y plus 18 squared equals to 15 squared. So that's the standard form. Because our coordinates are negative, so ends up becoming a plus. So upon expansion and simplification, we get the general form. And then we compare it . Okay, to your x squared plus y squared plus 2gx plus 2fy plus c. This one given in the question. So we just do comparison. 6 compared with 2g. Okay, then 36 will be equals to 2f, and plus 108 will be equals to plus c. Okay. The question did specify for us to know what is f, g, and c. So to answer the question completely by stating out what is f, g, and c. Okay. I want to challenge us a little bit. Is this the only way of solving, okay, for us to find out the radius of the big circle? Okay. What I've done over here is that I make use of very intuitive ideas that area of circle is pi r squared. Okay. But I want us to think about, okay, whether this is the only way of solving or not. Okay. One very important thing about circle is that all circles are similar to each other. Do we agree about that? Remember what is similarity? Similarity of figures would mean that they are proportional to each other. So for your circles, right, okay, comparing a circle with radius 2 cm versus a circle that has radius 8 cm, it is 4 times larger. Okay, they are always proportional to each other. Agree? All circles are proportional, okay, they are similar to each other. So using the similar figures concept, right, okay, we can actually avoid using the area of circle to find out what is the radius. So let me show that to you over here. Yeah? Our radius R1 over R2, okay, is relationship to the area A1 over A2. Okay, the ratio of the radius will have to be square it has to be squared in order to be equal to A1 over A2. Remember this? We learned this last year regarding similar figures. Area is always the square of the length. Radius is the length itself. Agree? So the radius 1 over here is our radius of C1, that is 5. Okay, radius of 2 is what we want to find. Square it. Area of 1 over area of 2. We make use of this information here, which tells us the area of C1 divided by area of C2, okay, equals to 1 over 9. So just manipulating things. Okay, I divide area of C2 over, divide by 9 to the left hand side. Okay, so they follow this. So therefore, I will have 1 over 9 over here. Okay, then now, that means 25 over R2 squared equals to 1 over 9. Cross multiply and all that. Okay, we find that the areas of the radius of the second circle will be 225, which will then proceed to give us the radius to be 15 or so now. Okay. I want us to also be aware about such a concept. Okay, you never know when will it be helpful, but nothing wrong if you actually do it in this manner. Okay. Okay with me going another question? Or is this already too much? Too much already? Too much already? Okay. I know some of you can go on, okay, but I also see that some of you are taking a lot, okay, to digest all this in. Okay, then I think I'll just stop here for today. Okay. Tomorrow, we will continue. I hope that tomorrow we can actually finish up our circles so that Thursday we can actually start on our differentiation. Okay? Then I also want to return to you your homework, okay, for your E-Maths chapter 2. Okay, do you want me to return you your homework tomorrow or on Thursday? Tomorrow, E-Maths, okay, then tomorrow I return, okay, then I may not finish up the circles, okay, then I will finish up circles on Thursday, and Thursday we will also start on differentiation, okay? Okay, do go back and then after that, let these ideas, okay, sink onto you, okay, get stick it to your brain.